today I will investigate with you the relationship between light intensity, and gas exchange in plants. Alright? So today's focus, I will talk about the relationship between gas exchange and light intensity. And then secondly, I will teach you to design an experiment to show this relationship. Alright? So remember this photograph. So that's the flowers that are in my plants that I introduced to you last lesson. So do you remember? So what are the basic elements that this plant requires to stay alive? So that is carbon dioxide, sunlight, mineral, and water. And then last time one of you cleverly suggested that oxygen is also a part. So can you see the word? Oxygen is also important for the survival of the plant. So can anyone tell me where does the plant get these elements again? So in fact, last lesson I've already told you. Thank you. Number 23. Yes, hello. So which organ does the plant use to get sunlight? So for photosynthesis, where? Which organ? Yes, leaf. How about CO2? So leaf again, yes. And how about mineral? From the soil, from the root. And then how about oxygen? Leaf, thank you. Well done. So in fact, sunlight will be by leaf, and CO2 will be by leaf also, and then mineral will be by roots, and then oxygen will be by leaf, and also oxygen can be obtained from photosynthesis. Okay, and then however, sunlight will affect the absorption of CO2 from the environment, and today I will talk about these events. Alright? So gas exchange revisited. So let's fill in the blank on your worksheet. Alright? So that's the question one. So which are the three organs in which gas exchange occurs in plants? So from last lesson. Number 5, Yes. So what are the three organs here? So in fact, it's the three basic organs of a plant: leaves, then roots, and then stems. Thank you. So in fact, it is leaves, stems, and roots. So in the leaves, so through which does the gas exchange occurs? There is a hole on the leaves. There are holes on the leaves. So how to call those holes? How about you? 35. The hole. Excellent. So how to call the hole through which the gas exchange occurs is stoma. Thank you. Or in plural form is stomata. Stoma is the singular form. So how about the stem? So there are two kinds of plants. So the first kind is herbaceous plants. So in herbaceous plant, it is through which 36. So 唔清楚 can. Yes. So in herbaceous plants, through which hole? It is quite similar to the leaf. So quite similar to the leaf. In fact, the same to the leaf. Yes, stomata. Thank you. So how about woody plants? So a very difficult name. The number is so large today. 33. ห้อง So in woody plants, it is through another name for the hole. So how to call that hole? Start with L. So remember there are some permeable area on the woody stem. So how to call that permeable area? Lenticels. So quite near is lenticels. Thank you. So through lenticels, so the woody plants will perform the gas exchange through the lenticels. All right. So lastly, the root. So it's very simple. It's a very simple process that you learn in Form 3. So what's that? A large number and 黃金啊 29. Self diffusion. Thank you. So this is the whole picture about the gas exchange in plants. All right. Finish. And then now I will tell you about how light intensity affects the gas exchange in plants. So photosynthesis and respiration. So can anyone recall me about the word equation for photosynthesis? So that's a question that I always ask you. Oh, you are here. So, what is the word equation for photosynthesis? Yes. And then water, and then
sunlight.
Yes, in the presence of sunlight, and then starch. So before starch, a molecules will form. So yes, glucose. Thank you. So in the presence of sunlight, so carbon dioxide reacts with water to form glucose and oxygen. So that's the word equation for photosynthesis. So how about respiration? Number 9. No. CO2. So CO2 plus water will be this one. How about this one? Respiration. So in fact, this is some kind of reverse reaction for this glucose, and then yes, thank you. So in fact, this is the reverse. So glucose reacts with oxygen, or glucose is oxidized to form carbon dioxide and water. All right. So I put forward some question for you. So you compare the rate of these two processes. So you know these two processes are two reverse reactions, right? Two reverse reactions. So when photosynthesis occurs much faster than respiration, and then what will be so will there be an uptake or a release of carbon dioxide? So when this equation occurs much faster than this equation, so will there be an uptake or a release of carbon dioxide? Number 25,
Uptake.
Yes, there will be a net uptake of carbon dioxide. Thank you. So how about when respiration occurs much faster than photosynthesis? So obviously there will be a net release of carbon dioxide. Alright, so remember when photosynthesis occurs much faster than respiration, so there will be a net uptake of carbon dioxide. So on the other hand, when respiration